Hi everyone, my name is Lukas Picek and I'm here to introduce the Danish Fungi 2020, not just another image recognition dataset, which results from joint efforts between citizen scientists, mycologists, and machine learning experts. The dataset came along with a number of unique characteristics, such as full taxonomic labels with expert or community-based validation, rich observation metadata with information about substrate, habitat, location, time, EXIF, and many more, with highly unbalanced long-tail class distribution where most frequent species is represented by almost 2000 images and the least present with 31, with zero overlap with ImageNet, and lastly with an extraordinary inter and intra-class similarities and differences. To show you the high intra and interclass similarities, I have prepared few images from three distinct genera: Russula, which is on the left side, Boletus in the middle, and Amanita, which is on the right side. To make it even more interesting, I mixed three poison species and their edible lookalikes together. In some cases, the DNA sequencing is the only way how to predict the species correctly. The Danish fungi dataset, in short DF20, is constructed from observations submitted to the Atlas of Danish Fungi that uses an automatic fungi recognition system. The DF20 consists of approximately 300,000 images belonging to more than 1,600 species. Besides DF20, we'd introduced DF20 Mini, a small subset with roughly 1/10 of the data and species for fast and low energy friendly prototyping. To establish a baseline performance on DF20 and DF20 Mini, we perform multiple experiments. First, we train and validate a wide variety of well-known CNN architectures. Second, selected CNNs are compared with vision transformer architectures. And finally, the impact of different metadata and their combinations on both the CNN and the vision transformer architectures are evaluated. The best performing CNN in terms of top 1 accuracy was the Ceresnext 101 with an accuracy of 77%, thus showing that the top results on DF20 are far from being saturated for current state-of-the-art architectures. In the second experiment, where we compare the CNNs with vision transformers, which unlike CNNs do not use convolutions but interprets an image as a sequence of patches and preprocess it by a standard transformer encoder, as in natural language processing, we showed that VITs achieved superior performance to the CNN baselines in the fine-grained classification. For the usage of the metadata, we propose the following simple procedure. Assuming that the visual appearance of a species does not depend on the metadata, then the species posterior given the image and metadata is easily obtained as described in equation 2. Anyway, this does not mean that the posterior probability of the species given an image is independent of the metadata. To utilize several p-types of metadata at once, we combine the posteriors assuming statistical independence. This is a simple baseline assumption which again may not always be valid for relevant metadata. By using the proposed method for metadata integration into the classification process, we increase the performance in all measured metrics. More precisely, we improve the vision transformer large model performance by 3% in top 1, 2% in top 3, and 5% in macro average F1. Before the end of my presentation, I would like to invite you to the competition that features our datasets and is already accepted at LiveClef workshop and is awaiting for approval at CVPR FGVC workshop. The competition should help to tackle common issues for machine learning-based applications. First, we want to explore the classification beyond 0-1 cost, and we want to include the edibility of the mushroom into the decision process. Next, we introduce a special test set with 2 times more species than in a training set, thus preparing a challenging scenario for current computer vision methods. If you consider these as interesting research topics, please do not hesitate to register for the LiveClef Lab at the given link. At this point, I would like to first thank you for your attention and second, to share QR links to our fungal atlas.